So I'll start off with I guess one of the initial issues. There have been many, but this is sort of the issue where it's been talked about the most. So Go 114 changed the behavior with respect to one of the JSON types of JSON.number. So if you're not familiar with JSON.number, it's kind of this type of number literal in Go's version of JSON package that has a bunch of helper methods to it that can sort of move you back and forth between string, float, and just makes it a little bit easier to work with if you're expecting your JSON to have numbers in it. So you can use a regular string or a regular float or a regular int to parse or to unmarshal back and forth your JSON object that has a number. But with this, it makes a little bit easier if you want to use these helper methods with it. So in our case, we were using this, and turns out that there was a change that was made to upstream Go in 114 that sort of breaks it in a way that is proper according to the RFC, the spec, but it's not good in terms of backwards compatibility. So I'll show you how it is not good and how we managed to fix it. So like I mentioned, there's this thread, that has like lots and lots of people trying to explain what's going on, but this thread is mostly about documentation and people sort of convincing each other that we need this change, and then there are people that are trying to say that we don't need this change because it's backwards breaking. But anyways, the gist of it is that this issue led to the documentation of this problem, or fix, I guess, in some sense, which is this tiny line in the Go 114 release notes. And, it's like I look at these release notes whenever a Go version is released just to see what's new. But to be honest, like this is kind of very subtle. Like, and I actually never recall looking at this when I was looking at 114 release notes. And it says that JSON number no longer accepts invalid numbers to align closely to the spec. And then there's a sort of a workaround that you can use if you still want to use them as you were previously so that your programs don't break. So this is what the behavior was documented, but now I'll show you in action of how it actually looks like. So previously, this is what we used to have. We used to have a JSON number type for CVSS score number. This will make a little more sense when I show you the examples, but just keep this in mind that it used to be JSON number, and then we used to tag anything that had a JSON object with the tag of CVSS score into this structure member. And then previously, because it was like this, all we had to do was to unmarshal our JSON by making an object of raw advisory struct and then taking in the JSON object and decoding it into this struct, and then all fields would come out as we expect them to be, and then we can play with them. So that's how it used to look like. But after this change in 114, this stopped working. So if you see my ID now, this is what sort of broke. So previously, we used to have JSON number, as I said, and the reason we used to have it was we needed those helper methods that I mentioned, but the thing that broke is basically this one line in some of the node JS vulnerability information. So node likes to specify a CVSS score that has um, one of the three things. So one is it has a score. The second, it has a score and a severity. And the third is it has a null. So in this case, as you can see on the right, it happens to have a severity with a level. And then, this is represented as a string. And then previously, JSON number will take this, accept it right away, and treat it as a string, and then go its way to to be used. Now this doesn't work anymore. This is treated as an invalid string or invalid JSON number, and then that's what breaks most of the programs that people have written in the past that are not compliant to the spec of JSON number, but were working because of the missing feature or missing, I guess, spec compliance. So if you take a look at the other types, so sometimes it's a number, which is what it should be. Sometimes it's a number in a string, like I mentioned, and it breaks. And then sometimes it's a null. And there's a whole lot more to this type, why it exists and the way we found it, but it's a separate topic of its own. I don't want to get into it because it's not really relevant to this, but just keep in mind that there are, three types of things that can happen. So if you take a look on the left, the way to sort of go by it is like the release notes mentioned, is to define a custom unmarshaled JSON func for your type that you're looking for, and then it sort of does a reflection on the type that is present at the moment. So in this case, it's a simple switch case that does see if it's a float, string, or something else. Then this unmarshaled JSON is basically called every time you do a call to new decoder.decode. So previously, all you had was this, and then Go would call the unmarshaled func of the default type, and then everything would go by its way. But now, since raw advisory contains a CVSS score number, which is of type number, not a JSON number, it needs to be told how to unmarshal this type. So that's why we need a unmarshaled func for this type. This was a good exercise in not only sort of I guess finding out the things the hard way, but it is also a good exercise in a way where like we only noticed this when Tepe ran a feature request that I had pulled on Go 114. So this project TrivyDB was being built on Go 113 in the CI, and as soon as we upgraded to 114, it broke. So it was an exercise to sort of keep our code pipelines up to date with the latest stable release of Go, and also to sort of take another look at how we were testing some of our stuff. So previously, this code, because it was very simple and very straightforward, there were no tests, so it was it was broken until we actually updated the Go version and then found that, oh yes, it doesn't actually work anymore. So previously, if we were to get an input of a JSON like this on the right, it would have worked in unexpected ways. After adding these tests and having a bunch of other test cases here, like as you can see on the right, it sort of made things a little better than how they were before, and we still have room for improvement for other type of other vendors like Red Hat and others which don't have this level of testing at this point. But anyways, the point being, um, this is a change that happened in 114. It's subtle. It might bite you, especially with your old programs if you're using it. So yeah, that's what I found.